welcome to True Projects. In this video, we are going to discuss about the project which is potato leaf disease classification using machine and deep learning. So let's understand what is the project about. Potatoes are important for food as well as farmers' income worldwide, but they often get attacked by diseases, especially leaf diseases, which harm their production, growth, and quality. So detecting these diseases early is vital for controlling them. So traditionally, farmers used to inspect these diseases visually, which is time consuming and subjective. However, there has been rise in the deep learning, that is use of deep learning, which is a type of artificial intelligence to automatically detect and classify these diseases. So this approach offers faster, more consistent and potentially more accurate results, promising better disease control and protection for potato crops. So, the main aim of the project is to create an accurate method for spotting and categorizing these diseases early. So, the author in the base paper he proposes the technique called convolutional neural network, which is a type of deep learning model to classify potato leaf diseases. So, this would help farmers respond promptly to control the spread of the diseases. The process involves preparing the leaf images, training the CNN model with these images, and then checking how well the model performs on a separate set of images. Essentially, it is about teaching a computer to recognize different potato leaf diseases from images so farmers can take action quickly when needed. So, as an extension to this project, to boost the disease classification accuracy, we incorporated advanced models called exception with DenseNet and voting classifier. So, this ensemble method combining the strengths of each model results in improved accuracy levels. After careful evaluation, the combination of exception and DenseNet, so the combination of exception and DenseNet has proved most effective and it was chosen for the deployment. So, this decision ensures that the project delivers the best possible results, aiding in agricultural disease management efforts effectively. So, moving on, algorithms which are used in the project are KNN, logistic regression, decision tree, voting classifiers, CNN, DenseNet, exception, and combination of exception with DenseNet. So, exception with DenseNet is our proposed model, and CNN is according to the base paper. And we also built machine learning models for comparison purpose. So among all the models built, we found that exception with DenseNet is performing well. So we chose it for deploying it in the front end. Also as an extension, we integrated Flask framework for building the web application. So what is this Flask? Flask is like a lightweight web framework for creating websites using Python. So we used Flask in this project to make a website where people can interact with our potato leaf disease classification system. With Flask, we can set up features like sign up and sign in using a simple database called SQLite 3. So users can give the images on website for analysis. Flask helps to manage all these interactions by directing them to the backend of a project, that is write parts of a project, where images are processed and predictions are made. So this way users can easily use project through a web browser. Furthermore, to implement this project, we need software and hardware requirements. Coming to the software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. And coming to the hardware requirements, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now let's execute the project. To execute, we need to open the code folder which contains source code files. So these are the source code files in the code folder of a project. Before executing, let us understand each file, how will they be used in the project. So here in the first folder, we have the data set. So open the folder. There are three different classes of leaf disease. The first one we have is potato early blight. The next one we have is potato healthy. That means there is no disease in these leaves. And the last folder we have is potato late blight. So it belongs to late blight disease. So let's see images in it. Let us open potato early blight images. So here we can observe there are potato early blight images. So we'll be using all of these images to train the model, all the models. Now get back. Here we have potato healthy images. So these are healthy images. Now get back. In the last folder, we have potato late blight images. So we'll use all these images to train the model. Get back. So we'll be using all of these three folders to train all the models for classifying the potato leaf disease. So by combining all these three folders, we stored images in the output folder in train and validation. So we use train folder for training the models and validation folder for evaluating the models. Now get back. Coming to the sample folder, here we have three more subfolders, that is early blight, potato healthy, potato late blight. So images in these folders will be using them as test cases to detect potato leaf disease in the front end. So we'll be using all of these images to detect the disease in the front end. So these are of early blight, these are of healthy images. And in the last folder, we have late blight. Now get back. This is the static folder, and this folder contains files related to CSS, JavaScript, and Bootstrap 4. And these files, they are important for project styling and the interactivity. Moving on to the next folder, which is templates folder. Here lies all the HTML pages utilized in the project. They are index.html, about.html, etc. And each HTML file represents a different page of the website and provides structure and layout for displaying content to the users. Moving on to app.py file, this file encompasses front-end logic of the project and it is a Python file. And it handles server-side operations, including processing user requests, interacting with the database, and dynamically generating content to be presented in HTML templates. And here we have model files. So these are the model files. So these files, they contain the algorithm information, and these will be loaded into the project code during runtime. And this is notebook.ipynb file. This is the Jupyter notebook file which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, which is a popular choice for the data science. And this is signup.db file. This file is a database file which is used to store the user information. Now let's execute the project. So copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the Anaconda prompt. Using the command cd followed by the space, paste the copied path and now click on enter. Here we can observe that current directory is changed to the code folder's path. Now compile app.py file by giving the command python space app.py and now click on enter. So this command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So it is taking time to run. Here we got the link. So this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. So I copied the link. I prefer Google Chrome, so I'll paste it in that. Paste the link here and now click on enter. This is the web page of the project, which is displayed in the browser, and this web page is built using Flask framework. So we need to sign up first. So click on sign up link and enter all the registration details if we are registering newly. I already registered and I have an account already, so I'll directly sign in. So click on sign in. And here we need to provide username and the password. Now click on sign in. We have signed in successfully and we are redirected to classification page. So here we can see a choose file button. We need to click on that for uploading the potato leaf images. So click on choose file. We have test cases in the sample folder. So open that. Here there are three subfolders in it. One is potato early blight, potato healthy, and potato late blight. So first let us upload images from the early blight and see whether the application will correctly predict as early blight or not. So open it. I'm going to upload the second image. Click on open. So here we can see that image is loaded. Now click on upload. Here we got the classification. So this is the uploaded image and here it has predicted as potato early blight. So the application has correctly classified this leaf as potato early blight. With this, we can understand that the potato leaf is affected with the early blight disease. So scrolling down, we can see that here is the description for the early blight disease, and here are the symptoms if potato leaf is affected with the early blight disease. And if the leaf is affected with that disease, here are the control measures for that. So by using these measures, he can prevent from the disease. So let us upload some more images. Click on classification, click on choose file. So now we will upload this image. Click on open. Image is loaded. Now upload it. So here we got the prediction. This is the uploaded image, and here we got the prediction as potato early blight. Application has correctly predicted it. So here is the description for that. Symptoms of early blight if the potato leaf is affected with the early blight. And if it is affected, here are the control measures for that. Let us upload one more image. Click on classification. Click on choose file. So now we will upload this image. Click on open. Image is loaded. Now upload it. So here we have the prediction, that is application has classified the leaf as potato early blight. So this leaf is affected with the potato early blight. Based on the symptoms, the application will predict it as potato early blight. So here is the introduction, symptoms, and control measures. So let us upload one more image. Click on classification. Click on choose file. So now we will upload image, this image. Click on open, and now upload it. So here we got the prediction as potato early blight. The application has correctly classified it as early blight. So now we will try using some more test cases of the other class. Click on classification. Click on choose file. Now we will upload healthy leaves and see whether the application will correctly predict as healthy or not. So open the folder. We'll upload this image. So here we got the prediction as potato healthy. It means that potato is healthy. It is not suffering with any disease. Let us upload some more images from the same folder. Click on classification. Click on choose file. So now we will upload this image. Click on upload. So here we got the classification. This is the uploaded image, and here we got as potato healthy is detected. That means that potato leaf is healthy. Let us upload some more images. Click on classification, and now click on choose file. So now we will upload this image. Click on open. File is loaded. Now upload it. Here we got the prediction, that is leaf is classified as potato healthy leaf. So now we will upload images from the other class, that is late blight. Click on classification. Click on choose file. Open the late blight folder. So upload this image. Click on open. Image is loaded. Now upload it. So here we got the classification. This is the uploaded potato leaf image. And here we have prediction as potato lead blight classified. It is classified as potato lead blight. And this potato leaf is affected with the lead blight. And here we have description for the late blight disease. And these are the symptoms of late blight disease if a potato leaf is affected with that. And here we have control measures for that. Let us upload some more images from the same folder. Click on classification. Click on choose file. So let us upload this image. Click on upload. Here we got the classification. This is the uploaded potato leaf image, and here it has predicted as potato leaf blight. And here we have introduction for that, that is description, symptoms, as well as control measures. So we will upload the last image from the folder. Click on classification. Click on choose file. So we will upload this image. Click on open, and now upload it. And here we got the prediction. This is the uploaded image and it has predicted as potato leaf blight. It is classified as potato leaf blight, which means that this leaf is affected with the leaf blight disease. And here we have description, symptoms, as well as control measures. Now click on classification. As of now, we have used local folder, that is sample folder, to detect the disease, that is to classify the disease. Now we will try using some Google images. So open the new tab. We will search for early blight leaves. So we will save some images. We will try this image, so save it. Get back to the application, click on choose file. We have saved this image, click on open and now upload it. So here we got the prediction as potato early blight. We can observe that the application is also working well with the Google images, not only with the local folder. So now we will try using some more images from the Google. Click on classification, click on new tab again. So now we will save this image, save it, get back to the application, click on choose file. So we have saved this image, click on open and now upload it. So here we got the prediction. This is the uploaded image and here we got the correct prediction, that is potato early blight. So this leaf is suffering from the early blight disease. And here we have introduction, symptoms and control measures. Now we will try using healthy leaves. So get back to the Google, search for potato healthy leaves. So we will save this image, get back to the application, click on classification, click on choose file. So this is the image which we have saved. Open it. Image is loaded now. Upload it. So here we got the prediction. This is the uploaded image and here it has correctly classified it as potato leaf is healthy. So now we will upload some more images from the Google. Get back to the Google. We will search for late blight, potato leaves of late blight. So here we have some late blight images. We will save the first image. Get back to the application. Click on choose file. So we have saved this image. Click on open and now click on upload. So this is the uploaded image and here we got the prediction as potato late blight. So here we can observe that it has correctly predicted as late blight. So in this way, just by uploading images to the system, the application, it will classify whether the potato leaf is affected with the early blight, late blight, or whether it is healthy. It is not only working with the local folder, but it is also working with the Google images. So now we will see the graphs of the project. So click on graph link. So here we have loss and accuracy curve graph of exception with density model, that is ensemble model. So this graph represents the loss graph and this is accuracy graph. Here on x-axis we have number of epochs and on y-axis we have loss score. And in this graph also on x-axis we have number of epochs and on y-axis we have accuracy score. In this both graphs, blue color represents training loss and training accuracy and orange is the validation loss. So in this loss graph, we can observe that with every increase in epoch, loss is being decreased. And here in the accuracy, with every increase in epoch, accuracy is being increased. With this, we can understand that model is performing well. Moving on, here we have accuracy comparison graph, where on x-axis we have accuracy score for each algorithm and on y-axis we have algorithm names. And here we have precision score comparison graph, This is precision score comparison graph. This is recall score and this is FN score. So all the models which are built, they are evaluated using FN score, recall, precision, and accuracy. So now click on sign out. So this project demonstrated the efficacy of employing advanced deep learning models and ensemble techniques for automated disease detection. Through evaluation, the combination of models like exception and density was identified as the most accurate and thus chosen for the deployment. This highlights the potential of such technologies to significantly improve disease management efforts across various agricultural contexts.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.